We now want to factor this. Once again, we start by figuring out what they have in common. And in this case, it's a 4. When I remove the 4, I'm left with 49x squared plus 70x plus 25. And the key here is to remember the shortcut. In general, a squared plus 2ab plus b squared is equal to a plus b squared. This is one of the harder of the factoring shortcuts to recognize. However, it's not impossible. The key is to look at the first and last term and realize that they are perfect squares. This is 7 squared and 5 squared. And then see if the middle term fits. 7 times 5 is 35, times 2 is 70, so yes, it does fit this problem. Therefore, I have 4 times 7x plus 5 squared. Here's our next factoring. This is a difference of cubes. While all of the other factoring techniques and shortcuts that I used can be solved by brute force using our traditional methods of factoring, this one cannot. And unfortunately, this is one where you have to be familiar with the formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. It might be difficult to remember the signs because if we switch these and do a cubed plus b cubed, this would factor to a plus b, a squared minus ab plus b squared. In general, your signs are the same as your original problem, the opposite of the original problem, and then always positive. For this particular problem, a is going to be 3, since 3 cubed is 27, and b is going to be 2y, since 2y cubed is 8y cubed. When I use my formula, I then have a minus b times a squared, 3 times 3 is 9, plus a times b, so that is 6y, plus b squared. 2 squared is 4, and then y squared. This time, we have the sum of cubes. And like I just said, we did have a formula for that. A cubed plus b cubed is a plus b, a squared minus ab plus b squared. However, this actually doesn't look like the sum of cubes since 875 is not a perfect cubed and neither is 189. However, the real first step for factoring is to see if they have anything in common. And these do. They have a 7 in common. When I remove the 7, I'm left with 125x cubed plus 27. And now we actually have the sum of cubes. In this case, a will be 5x, since when I cube that, I get 125x cubed. And b will be 3, since 3 cubed is 27. So I have a plus b times a squared, which would be 25x squared, plus a, or minus, a times b is 15x, plus b squared, which is 9. Now let's factor this one. Once again, we always start by seeing if they have anything in common. These do have a 2 in common, and they also all have an x. When I remove that from the first term, I'm left with x squared. The second one will give me negative 3xy, and then the last one, negative 10y squared. To finish factoring this, the only thing that's going to multiply to be x is x and x, or x squared is x and x. And now I really just need numbers that multiply to be negative 10 and add to be negative 3. We can try a few things, but there's only a few things that actually multiply to be 10, like 2 and 5. And if I do a negative 5 and a positive 2, I can see that negative 5 plus 2 gives me the negative 3 that I needed. We now want to solve a quadratic equation. The first step to solving quadratics is always to get everything on one side, so let's do that. I now have 6b squared plus 25b plus 25 equal to 0. And now we need to try to factor. This factoring is slightly more complicated because of that 6. However, we can use what's called the AC method, which says we start by multiplying the first number and the last number. 6 times 25 is 150. And I now need numbers that multiply to be 150 and add to be 25. And I can see pretty easily that that works with 15 and 10. So I'm going to rewrite this problem as 6b squared plus 15b plus 10b plus 25 equal to 0. And we'll now do by grouping. My first two terms only have a b in common, rather a 3b in common. I'm then left with 2b plus 5. My second terms have a 5 in common, and I'm left with 2b plus 5. And then I can factor and get 3b plus 5 times 2b plus 5. And we are almost done. Now we just need to actually solve the equation. If we have two things that are multiplied to be 0, we can assume that one of them is 0. So I have 3b plus 5 equal to 0. I can subtract 5 from both sides, and then divide by 3 to get b is negative 5 over 3. I also need to set the other one equal to 0. I can subtract 5 to get 2b equal to negative 5, and then divide by 2 to get b is negative 5 over 2. So we have two answers, negative 5 thirds and negative 5 halves.